Today we have serialization formats aren't toys with Tom Eastman. Tom is a senior Python developer and technical lead for Catalyst IT, New Zealand's largest company specializing in open source. Prior to that, he worked as a developer and system administrator for the University of Otago Faculty of Medicine and as a computer science tutor for SAME. Tom is also the director of this year's Kiwi PyCon and will be spending significant amounts of time trying to convince you all to fly to Wellington for more Python fun 5 weeks after PyCon AU has concluded. Thank you, Tom.
You guys should all fly to Wellington 5 weeks from now. Sorry?
I would love to. Are you paying?
Probably not. So my name's Tom. Feedbacky already. And I am an open source technologist. It says so. I'm even labeled that way. I'm a Python developer, and I have delusions of DevOps. I'm not a security expert or a penetration tester, but all my drinking buddies are. And so I've developed a healthy paranoid worldview because I don't like it when they break my toys, which actually one of them's doing tomorrow. A contractor is going to be breaking my project I've been working on for 2 years, which is going to mean that I'm going to be a little preoccupied during the sprints. And who are you guys? Who here today is actually in the security industry? Who's a penetration tester or a security tester or works for a security company or a hacker? Someone dangerous, that guy. He knows everything I'm going to be talking about today, and he's going to be smiling smugly through the entire talk. If you're an IT security professional, you already know all this stuff. If you're a developer, you might know it, but you might not. And you have to know that it's even a thing, or you're going to get in a lot of trouble without even realizing it. This is one of those topics where if you know about it, it seems obvious, it seems remedial, but the same mistakes keep happening over and over again. So some people just need to be told. So if this is new to you today, spread the word. I am going to be talking about serialization formats, or markup languages, or whatever you call them. I basically just mean formats that structure data in a way that doesn't suck so we can get information out of them. There's a billion of them in all kinds of languages and uses, and all of them have little surprises tucked away that you probably didn't realize when you just went, JSON.load or YAML.load. All of them are too smart for their own good. Today I'm just talking about 3 of them. I'm going to be talking about YAML, XML, and JSON. But they're just examples of my larger point, because this pattern just kind of repeats itself over and over again. Who's familiar with the OWASP top 10? The stuff that I'm going to be talking about is not on the OWASP top 10, because it's actually somewhere around 11 or 13, and that just means no one knows about it. Sorry, hands up who doesn't know about the top 10? OK, a couple, great. Google it after the talk and read up on the OWASP top 10. It is a yearly-ish, no, it's a bi-yearly compiled list of the top 10 web vulnerabilities. If you are a web developer and you are not intimately familiar with the top 10, you're a liability to your project. And that can be fixed. You just have to go there and you just have to read up on this stuff and learn how to defend yourself against these very well-known exploits that will be attempted on your sites. I've been working on a project for the last 2 years where one of the non-functional requirements was that defenses were in place for everything in the OWASP top 10. And I thought I had done a really good job of that, partly because I was using Django, and you get a lot of good defense for free. And then I went to a talk by a penetration tester named Mike Howarth, who's an old colleague of mine from university. And he showed me some stuff in XML that scared the crap out of me. And I went back from the pub, back to work, tried it out on my own project, and made my servers blow up. So I decided to take this more seriously. Because the problem is an attacker only needs to know one thing that you don't about the system that you're using, and they can break in. And there's a lot of things that you might think you know. And yeah, the really smart hackers know all of the features in all this software. So when you're using a tool and they can go, hey, I wonder if they knew to turn off such and such. Maybe you didn't because you didn't really care. Everything I'm going to talk about is not a bug. It is a feature. This is all stuff that when these languages were designed, this was intentionally put in as a thing that hey, what a great idea. Let's make sure XML does this. Hey, what a great idea. Let's make sure YAML does this. Nothing that I'm talking about today is a bug. The more compliant your XML parser is, the more vulnerable you are. Is that very readable to everyone in the audience? OK, so this is a really tiny bottle app. It's a little tiny web app. And it's doing something really, really simple, which is it has three endpoints. And if you post YAML to one of them, it just runs it through the Python YAML parser. And if you post XML to it, it runs it through the Python XML parser. And then the third one is actually the LXML Python parser, which is not the standard library one, but it's the one that practically everyone uses. And the key point that I want to draw your attention to here is in each of these examples, I'm doing the bare minimum that it would take to go from a text file with some XML in it to a useful data structure that you can use. Because when you think about it, loading data into your project, loading data into your program is the least interesting part of your day. You want to do that as quickly as possible. You don't care. You're using an IDE, and you go, OK, this is a YAML file, import YAML. Hey, we have a YAML module. YAML.tab, look at the autocomplete. Oh, there's a thing called load, YAML.load. It takes a file. We're done. And that's all you care about, because you want the data. You don't care about, that's as far as you're going to dig. So all of my examples that I'm going to just talk about here, we're just using this piece of code that I was doing just to check and see what happens. We'll start with YAML, because it's actually been quite topical lately. Thank goodness XML is not topical anymore. YAML's been around since 2001-ish, and it's really popular in languages like Ruby and Python, and probably none else. I don't know. Oh, Node uses YAML, doesn't it? It pretends to be a human-readable serialization format. Human-readable never works when it comes to actual serialization, does it? Okay, what we're looking at here is an example use of that silly little web app that I had written, which is I posted the text, its line numbers on the left, and I posted a bit of YAML to the YAML endpoint. And what I got back was a Python dictionary. OK, so is everyone with me so far? Yep. Really, really simple stuff. YAML just uses a key value that almost looks exactly like a Python dictionary anyway, and what I get back out is the parsed version of that Python dictionary. So far, so good. Key value, all strings. YAML has the standard set of data types. It has booleans. I know it has numbers. It's got strings. And then it has some extensions. And the extensions are actually really, really handy. Here's an example of one of them. So we've got my name, last name, email address. And then that snippet of YAML at the top there, that's a special tag that says, this is actually a Python object, which is a datetime.date. And so what it does is it grabs the datetime module, and it grabs the date object, and it passes in those arguments for the constructor. And then you get your object. Where's the security guy going? Is he grinning yet? So anyway. One of the cool things of the Python YAML parser is that if that module hasn't been loaded, it'll just go ahead and load it for you, because it's really convenient that way. Did a shiver go down anyone's spine just then? OK. So imagine someone was posting something to your YAML endpoint, and they decided to put that tag in. Sorry?
How tame.
Oh, yeah, we're just getting started. So suddenly you've got interpolated into the parse dictionary the contents of my project directory, my talk directory. And I was like, wow, that actually worked far better than I thought it would. How far can we go with this? So send in a Python thing, os.system, rm star. I thought to myself, am I sure I want to do this before I push enter? And I was like, push enter. And as you can see, I did the contents trick again, and suddenly, no files. So I had to rewrite that code that you saw at the start there. And I had to rewrite my notes for the talk. Luckily, there weren't too many files in there. You'll note that I was reckless and pushed enter when it says rm star. I didn't put rf there. There's some part of my brain still had a self-preservation instinct. OK, so that's egregious, right? Any YAML thing can run any shell command just like that. And of course, it's got access to the full Python library. Surely this doesn't happen in real life, right? So here's Piston and TastyPie in 2011. As far as I'm aware, the Django REST framework didn't have this problem. But it had other problems. We'll get to that shortly. So these both hit the same error really early on. They were just using YAML.load. And you could send, and this is actually a REST API, right? So it's open to the internet, and it's an open invitation for everyone to just run whatever command they wanted on your server, which is, software as a service, right? This is Puppet. I gave these guys so much more credit. This was the thing that actually prompted me to write this talk, because when this happened, I cried. I was like, no, Puppet, I believed in you. And the same exact problem. No. This is Ruby on Rails. Sorry, I've got my slides around the wrong way. This is Ruby on Rails, and I had no faith in them. And this is totally expected. And this is Ruby on Rails, and I have no faith in them, and it's totally expected. However, in Ruby's defense, the Ruby YAML parser does not go out and load the module. So the guys who exploited this Ruby on Rails vulnerability, which you probably remember from last year because everyone was laughing at it in the Python community because we're mean that way, they had to go through the Ruby on Rails code base until they found a thing that was already loaded in memory that would then eval code. And that's how they got their code execution. In the Python one will just load that module for you. The Python module will just load the exec for you. And here's the Puppet one. And this is the one that really disappointed me. And here's the Node one, and I didn't care. But you see, it's the same mistake every time. And they say, hey, maybe you should use safe load instead. And maybe it should have been safe from the start. But actually, the Node one's hilarious because there was no such thing as safe load until someone started exploiting this, and then they wrote safe load really fast. So I've preempted myself a little bit. How do you protect yourself from this one? You've got to make the parser stupid. You've got to make it stupid enough to be safe, because people are going to take advantage of whatever you expose to the wider world. In Python, this is really, really easy. The YAML module has two methods. One's called YAML.load, which is what I was using. The other one is YAML.safeload. It does what it says on the tin. But Ruby, you have to do something a little bit weirder. You have to get an extra Ruby gem that sanitizes it, which goes in and monkey patches the YAML library to do the right thing. And that sounded really weird to me until I talked to a Ruby developer, and they said, yeah, that's just how Ruby works. Everything just monkey patches everything. But yeah, that's YAML, and YAML's got nothing on XML. So who uses XML in their day job? Last time I gave this talk, I didn't, and now I do, because I had to rewrite my project to incorporate SAML. So now I have XML facing the wild, and it's being pen tested tomorrow. And you'll see shortly why I'm nervous about that. I was going to think of something else to call this section, like fun with XML or dangerous XML, but just having that word up there is scary enough. So, sorry, who has used XML? Everybody, great. So this is totally familiar to everyone. This is a tiny little XML file, and it has an entity in it. And that entity is for a Unicode character, which is actually that little smiley face right there. So everyone's with me so far. But XML is more than just kind of a declarative elements and attributes and text thing, because you can define XML documents in XML. And so you can put something in there like doc type foo. So now I've created a thing called a document foo, and in that I've created an entity called smiley, which is just that same entity that I was using a second ago, but now I have a little alias for it. So ampersand smiley now means that Unicode character, and the response that you get out of the XML parser is exactly the same. So I've just defined an element and just made life a little bit easier for myself. And that's, I think, how all of the element entities and stuff in HTML and all those sorts of things are built. at least in XHTML. But you can do it recursively. So I've created there an entity called S4, which is a whole lot of S3s. And an S3 is defined as a whole lot of S2s. And S2 is a whole lot of smileys. And suddenly, in my actual document there, yay, smile with an S4 in it, I get a couple hundred smileys. Who's having fun so far? Who knows what the name is for this? This is called the billion laughs attack. Oh, shit, I have it in the title. OK. Actually, but that's a lie anyway. This is not the billion laughs attack. This is the 168 million laughs attack because I cropped one lull off of each row to just fit it on the side. So it's only 168 million. Now, you see that response smoking ruin right there. The simple fact is your XML parser tries to do all of that in memory, and it blows out 2 terabytes, and you get at least you get a 500 of some kind, and you might get an out of an killer on your Linux box or a segfault or whatever, but it all falls over in a heap. And on my little parser, I never got to try this because I copy and pasted the billion laughs attack into my editor, and I was about to run it on my, just curl, upload it to my little service, but my laptop exploded and died. My editor had decided, oh, he's typing XML. Let's make sure it's valid. So I DOSed myself before I could even DOS myself. I'm an Emacs user. Yeah, so Emacs is really helpful with its XML until you're trying to craft dangerous XML. So that's a memory attack. That's an XML bomb. It's really similar to a gzip bomb or a zip bomb. Or did any of you, when you were young, or more like last week, compress 10 billion zeros and email it to someone, and then they would unzip it, and their computer would fall over? That's literally all this is. It's the same deal, just you can do it to enterprise web systems. And the more enterprisey, the better, because they all use XML. So that's just a bomb, and maybe you can protect yourself from that by limiting the amount of memory that your XML is going to use. But entities don't have to just be defined in your document. Entities can come from anywhere. So I can define an entity called LSB release, and I can point it to a URL. That works just fine with the standard library Python XML parser. It will happily load etc password and just throw it into the XML document. And if you're running that on a web service, the XML will get put in. And if the user, for some reason, gets to see the XML, like if it shows an error, if it says, like, oh, there was an error in your XML, and it shows you your XML, it'll show you the parsed, canonicalized XML, which will have etc password in it, etc shadow in it. etc shadow is usually owned by root, but we're talking enterprise. And enterprise people tend to run their Java things as root when they're listening on the public internet. And you don't believe me, but I've been told it's true. But the guy who told me it's true refused to tell me who. And I can tell, I understand why. And of course, it can read its own source code, which means that it can read whatever files, whatever configuration files it has. So it could read, database passwords. And you could just find your way in from there. But it doesn't have to be a file URL. It can be an HTTP URL. Have you ever wanted to be able to do a port scan of someone's internal network just by playing with their XML server? Not me, because I'm a good person. But it works. And I know people who have played with this. You can send a piece of XML and say, yeah, let's just start exploring the internal network. And you're not limited to HTTP's port number. You can set that to port 110. And obviously, it's not going to give you an HTTP response. But if you time how long it takes to give you an error, you'll know if something was listening on that port. Seek out their internal SMTP servers. Seek out their internal POP3 servers. Explore their DMZ. Don't do this. You will get arrested. Yeah, so actually, I should have probably put a disclaimer at the top of this whole thing. Don't do any of this stuff except protect yourself from it. Surely this doesn't happen in real life. I'm not even going to try to show you a montage, but it really, really does. And it's one of the really, really important tools in a penetration tester's arsenal, because people are getting pretty familiar with SQL injection. And although SQL injection still happens, like it is still number one, the interesting projects are usually protected from it. Django is very well protected from SQL injection. If you're using the ORM, you're safe. Knock on some wood somewhere. I'm too scared that I'll find out this happens more often than it not happens. But it's an education problem. You're loading XML in, and thank you. You're loading XML in, and you're just wanting some structured data. But what you're getting is everything that XML offers, and XML offers more than that. And the better your parser, and everyone here knows better than to use regex to parse XML. And yet, that's safe, right? I mean, that's not at least going to start pinging outside servers. So how do you protect yourself from this? Unfortunately, because it's XML, all of this stuff is features of it. And it's really hard to protect yourself from this stuff because you basically have to cripple the whole system. This is sort of the standard checklist to make sure that your XML service is safe. And that's a lot of work to go through. But it comes down to the same thing, which is make the parser stupid. And thankfully, Python does have a solution to this now. Defused XML, I think it's actually intended to go into the standard library at some point. But it's a third-party library, which has sort of been officially sanctioned by smart people. And most of the web services that used to be vulnerable to this stuff, like the Django REST framework was vulnerable to some of this XML stuff up until I think it was March last year that they finally put diffused XML in there as an intermediary layer of their XML parsing. And that protects you from most of this obvious stuff. But in other languages, I haven't done that research. You're kind of on your own. And there's probably equivalents to sanitized and safe XML parsing in other libraries. But you have to know that you need to be using those, or you'll get caught out. So if you're doing projects in other languages, make sure you are aware of making the parser stupid enough that you're safe. So finally, move on to the last one, JSON. JSON is a really, really stripped down format. It might be finally stupid enough to generally trust, because it really is just strings and numbers, and I think Booleans, and key value and lists. And I think I just went through the whole spec. There's not even comments, right? So did I miss anything, or is that everything that JSON does? Sorry? No, null as well. So that's stupid enough to actually be safe, but only if you use a stupid enough parser. And what was the design decision that everyone thought, or the designers of JSON thought was incredibly clever? You could just use eval. Eval is not a stupid enough parser. Eval is a JavaScript interpreter. So if you're using eval to parse your JavaScript, you're in a terrible place. And surely no one does that in real life. But here we are at w3schools.com, and it's their explanation page about JSON. And check it out, right here. Eval can be used to convert JSON text into a JavaScript object. It's right there. It's their top recommendation. This is why JSON is so good. But that's W3 Schools. No one has any respect for them. Here's JSON.org. And there it is, right there in the explanation. Check it out. You can just use eval. Now, I'm being very slightly unfair because a little bit further down, about where my knee would be on that page, there's actually a little warning saying, oh, by the way, that might be security implications. Maybe you shouldn't do this. But why is that below the thing saying, hey, look how easy it is? Same thing here. It's a little bit further down the page, but it's there. They do have a little warning below, oh, you can just use eval. Now, someone trying to use JSON, what are they going to do? They're going to go, oh, you can use eval, and stop reading. And the warning saying you must not use eval is a little bit further down, which breaks my heart. So the lesson is beware of flexibility. If a tool sells itself as, look what I can do, watch out, because you don't want it to be able to do all kinds of things. You want it to be able to do the dumbest possible thing if it's exposed to possible bad actors at all. And when it comes to any of these things that are exposed to outside, turn off every single feature that you can possibly find that you're not using. Find them and turn them off. Keep it simple. Thank you very much. Are there any questions?
This is more of a fun fact than a question, but did you know that you can actually parse some JSON with Python's eval statement? And
yes.
I've seen that in production.
No. I didn't know the second part. But yeah, I guess like lists and a few other ones are close enough that you just totally could do that. Python has two. Someone will have to refresh my memory, but there's eval and there's exec in Python. And eval, there's actually another eval in Python now, which is only for the simple data structures. It's almost like the JSON of it. I don't remember what it's called. It's in the AST module. Can anyone refresh my memory? Does anyone know what I'm talking about? There's eval, and then there's a dumb eval that won't call functions or anything. It'll just parse lists and string literals and a few other things like that. Sorry? That's probably it. And you probably still don't want to use it. But there's a use case for that, obviously. Sorry? Let's not. Besides, there'd be underscores everywhere. It'd be really ugly. Any other questions?
Yeah, at the start you had an LXML and XML library that
Oh, I glossed over that because I did that research a long time ago, and I can't remember all of it, but here's what I think I remember. LXML, yeah, sorry, this is actually probably pretty, well, no. This would be important if there weren't diffused XML. The answer is use diffused XML, but LXML has memory protection. If you drop an XML bomb on it, it probably won't blow out the memory. You'll just get an exception thrown because it hits like 65K or something and says, hey, your XML is really big. Set this option if you really want to do this. The standard library one, I think, was happy to do the local file XXE is what that's called, external entity expansion. The standard library XML was happy to do that, but it was incapable of doing the URL one. And LXML, that's actually turned off by default. So in LXML, you have to turn on an extra option. It's one of the few places where the default is safe in XML. You have to turn on an option to allow it to ping outside servers to get external entities. So that was really the only safe default that I saw. The other point that I kind of want to make is that the culture is shifting. Modern frameworks, like I think Django's starting to do it, but they're starting to reverse that whole load versus safe load thing. Does anyone here use AngularJS? In Angular, they finally made the smart idea of when you're binding HTML to an element, you can tell I'm not a front-end developer, I don't know what I'm talking about, but that's called bind, and it does all the sanitization, it escapes the HTML. And if you want to use the one that is a possible risk of cross-site scripting, you have to use the one called unsafe bind, right? So you actually have to use the function that says unsafe in the name. That's what YAML should have done from the start. And so the culture is shifting. Modern libraries seem to realize that the default needs to be the safe one, and the unsafe one needs to be, make them type in, I really shouldn't be doing this, but. Is that right? That's giving Debian a lot of credit. I'm not sure. Anyone else? Cool. Thank you so much.